Hey guys, welcome to chapter 11. In this chapter, we're going to be examining the changes in prices, whereas last chapter, chapter 10, we were looking at the changes in the amount of products made by the country or the economy. This chapter is exclusively devoted to the way to measure changes in prices in the economy. So obviously it's a pretty big task to try to measure the average level of prices over hundreds of thousands of prices in a giant economy, but the tool that economists have settled on are two of them actually. One of them we talked about last chapter, and it was called the GDP deflator. In this chapter we're going to talk about the consumer price index, and we'll go ahead and compare and contrast the consumer price index and the GDP deflator, which are both ways to measure prices and not products. So let's get started. The big question is, with so many prices in the economy, how do we know which prices to actually measure? Well, the GDP deflator just measures every single product that is made. That's one way to think about it. The CPI takes a different approach. It measures the typical consumer's cost of living. So basically, you can think of things that a regular household buys. That's what the CPI measures, okay? It's really important because this is the basis of cost of living adjustments, known as COLAs, in many wage contracts and in Social Security. Any sort of defined income program that gives the same amount of income for many years or even a couple of years has to be indexed or has to be calibrated for the rising cost of the goods, the raising prices known as inflation, because otherwise at the end of that wage contract you will feel as though you are poorer than at the beginning just because everything got more expensive. Okay, that's called purchasing power, and the purchasing power is going down when prices are going up. Okay, so how is the CPI calculated? It's quite clever, really. The Bureau of Labor Statistics, there's this group here. They are the ones who have decided how this is done, and what they did was they decided to create this hypothetical shopping cart or shopping basket of goods that the typical household buys. So first they go and survey all the consumers to determine what a typical household buys. Then they go ahead and find the prices. This is actually incredibly time consuming because you have to get the average price for, say, a gallon of milk or the average price for a telephone or something like that over the entire United States. So it sends out agents all over the country examining the prices of milk in different places. Then it computes the cost of the basket, the shopping cart that they've created. Okay, and then once that's done, you do that for every year, and you choose one of the years to be a base year. And now you're going to actually compute the CPI, okay? Because we don't actually care about what the cost in the basket is, right? We don't actually care about the dollar value. That's kind of sounds more like something like GDP. What we're going to do is we're going to compare the two. We're going to compare the cost of the basket in the current year to the cost of the basket in the base year. All right, so we'll get that ratio and multiply it by 100 so that we have a number that's like 100 or 115 or something like that. Okay, and then finally, you just go ahead and calculate the inflation rate using the CPI, okay, for any 2 years. You're going to use this formula right here, which, lo and behold, is actually the formula for rate of change anytime in math. And in this class, you're always going to have to use this sort of a formula for rate of change. The basic form of it is the new price minus the old price divided by the old price, okay? Anytime I ask you for a rate of change of GDP or of any variable, you're going to have to use this formula for it. Okay, so let's get an example. Let's do a really simple model. Our entire shopping cart that we're investigating of each household consists of only 4 pizzas and 10 lattes. All right, and so here's some prices in each year. Now, in contrast with the GDP, remember the GDP, especially with the real GDP, what we try to do is just calculate the changes in product or productivity when we hold all prices constant. This is the flip side of it. What we're going to do is we're going to calculate the change in the overall price level when we keep the products constant, right? Because we're trying to measure the exact opposite thing here as in GDP. We're trying to measure the price, the changes in the price level. Okay, so we keep the basket, the quantity in the basket stable or constant, and then we just calculate according to the prices of each year. So in this year, the cost of the basket is $60, then it goes up to $69, and finally in 2012, it's $78. Let's go ahead and compute the CPI in each year using 2010 as the base year. So it's a very simple calculation. I just take the ratio of the CPI in this year to the CPI in the base year. Well, that's the same year, so it's going to be 1, and multiply it times 100. And so I get this thing right here that the CPI in the base year is always 100. Okay? What I've done is I've extrapolated or normalized away from the dollar value. See, there's no dollar. The dollar values are here, but in the CPI, there's no dollar value. It's just a number that tells you the ratio of how much the basket cost this year versus the base year. Okay, let's do the same thing for 2011. Okay, you see that it's 69 over 60 because I'm just comparing the price of the basket in 2011 to the price of the basket in the base year. So I have 115. I've extrapolated away from the actual cost of the basket, and I just know exactly it's 115% the cost that it used to be, or it's 15% more expensive. Okay, 2012, I do the same thing. I get a CPI of 130. In other words, the price is the basket costs 130% what it used to, or it raised up in price 30%. Now let's go ahead and calculate the inflation rate. Well, the inflation rate for the first 2 years is extremely simple. It was at 100 and it went to 115, meaning the prices went up 15%. That's how we get the inflation rate. If I needed to actually calculate it mathematically, I use this formula here, right? This is new minus old divided by old, same thing as always. Okay, and then from 2011 to 2012, well, if I were to ask you the inflation rate from 2010 to 2012, that'd be very simple. You look at it and you're like, oh, it went up 30%. But what if I asked you the inflation rate between 2011 and 2012? You're going to have to use this formula, okay? And they'll give you 13% inflation rate. All right, so go ahead and do these problems, this CPI basket, and calculate the CPI in 2011, and then find the CPI inflation rate from 2011 to 2012. So you'll end up having to calculate the CPI in 2011 and 2012. Hit pause, and then come back to me when you're all done. All right, so the CPI in 2011 was very simple. It's just the price of the goods times their quantities, and it's $150. And therefore, the CPI, excuse me, that thing we just calculated was the cost of the basket. So then is $150. I compare the cost of the basket in 2011 to the cost of the basket in 2010, which is the base year, and that gives me the CPI, or 125. Be careful, a lot of people accidentally write 150 for the CPI without realizing that what they're writing is dollars, okay? The CPI, any measure of price increase, is never in dollars. It's always in some ratio, or percent right here, what we have. All right, let's go ahead and figure out the inflation rate from 2011 to 2012. Let's calculate the cost of the basket in 2012. Okay, it's $210. Now I got to calculate the CPI in 2012, which I just compare it to the basket cost in the base year. So now my CPI is 175. Now I'm going to go ahead and calculate the inflation by looking at the changes in the CPIs, right? 175 to 125, and I get that the inflation rate overall rose 40%. Notice the individual goods rose a different percentage change than 40%, but we think of the household basket as a whole rising 40%. Okay, in real life, the CPI has many, many more goods than just pizza and lattes. Here's a brief look at what is in the CPI. All right, there's another problem. Well, there's many problems with the CPI. One problem I'm going to walk through with you right now, it's called substitution bias. Now, let's suppose that the CPI basket has 10 pounds beef, 20 pounds chicken, exactly like the last problem we did, and notice the prices here are changing as the years go from 2010 to 2011, 2012. So in 2010, 2011, the households, yes, they end up buying the CPI basket. But notice in 2012, price of beef shot up, whereas the price of chicken did not shoot up so much. It's likely that households will no longer buy exactly the CPI basket. They'll probably substitute away from the beef and buy more chicken. So let's say that in 2012, households bought instead 5 pounds of beef and 25 pounds chicken. All right, this is the actual basket. The problem is it's going to be a different price than the CPI basket, which is supposed to estimate what people bought. So what I want you to do is compute the cost of the 2012 actual household basket, this one that has 5 pounds beef and 25 pounds chicken, and then when you're done with that, compute the percent increase in the cost of the household basket versus the CPI inflation rate that you found the last example. Okay, so the 2012 household basket was $195. So notice the CPI is thinking that it's $210. That's what we calculated last exercise, because they assumed that everybody stayed with 10 pounds chicken and 10 pounds beef and 20 pounds chicken. But really what happened is they switched. They bought a little less beef and then a little bit more chicken. So the CPI basket is saying it's $210. So it's saying that the prices were at $120, then they went to $150, then they went to $210. But really they went from $120 then to $150, but then to $195 because the consumers bought different goods. Okay? So when we go to calculate the percent increase in the cost of the household basket, right? It went from 195 to 150. It went from 150 to 195, and that's only a 30% increase. But last problem, when we had calculated the inflation rate that the CPI thought, it was 40%. So you see that the CPI inflation rate is actually higher than the real inflation rate. What we're caring about, well, the thing that matters to us is how much the households have to pay, and that the increase that the households have to pay, that's 30%, whereas the CPI is trying to estimate it, but it's coming to 40% because of the shortcut that the CPI is trying to measure the same basket every single year, right? It's really one of the only ways to measure prices, because there's just so many prices. It's not a bad idea what CPI is trying to do. It's a bit of a shortcut to try to get around this problem. There's so many goods out there with prices. At any rate, it's overstating the inflation rate that our households are experiencing. So it's a bit of a problem. We call that substitution bias, okay? When some prices rise faster than others, consumers substitute towards the cheaper goods, right? You and I do this all the time. We stop buying the expensive good, start buying the cheaper good. And so our shopping cart, our hypothetical shopping cart that we have, is actually less expensive than the CPI, quote, shopping cart is, all right? So the CPI uses the fixed shopping cart, the fixed basket of goods, and therefore the CPI overstates the costs of living when we have substitution bias, okay? So the estimate is too high. Here's another problem with the CPI, is the introduction of new goods. This is kind of an abstract hypothetical problem, but it could play a role. So what we're really interested in is the well-being of our households and how much they're having to pay to sustain a certain level of well-being. Well, when there's new goods, this increases variety, right? When there's a bunch of different types of iPhones, for example, you can buy the exact one you want, and it allows consumers to find products that more closely meet their needs. So really, dollars become more valuable. Or another way to think about that is it takes fewer dollars to achieve a certain level of happiness inside of me and you and each one of us, because when new goods come out, we can get the actual exact good we need, so we need fewer dollars to maintain the same level of happiness. Okay? The CPI misses this effect, of course, because it uses a fixed basket of goods, and the CPI will end up overstating the cost of living in this issue also. Okay? Finally, let's talk about another problem with the CPI. It's unmeasured quality change. And the fact of the matter is that goods get better every year. Okay? And this has the effect of increasing the value of each dollar. The Bureau of Labor Statistics tries to account for these quality changes, but it misses some because quality is really hard to measure. Here's how it happens. Imagine that you're measuring the basket from 2000, and then you're going to measure the basket from 2014. Well, maybe they both have a Honda Accord in it because the average household is buying a Honda Accord. but it's highly likely that the 2014 Honda Accord is of much higher quality than the 2010 Honda Accord. So even though, let's say that the new Honda Accord actually even costs more. So the 2014 basket is going to look more expensive because the 2014 Honda Accord is in it and it's more expensive. But the increase in the price might not actually be just from a random price change. It might be because it's a better car now in 2014. So the 2014 basket looks more expensive, even though technically it's not more expensive. It's actually a productivity change. The 2014 Honda Accord is a better car than the 2000 Honda Accord. So the increases in price should be attributed to the increase in quality of the car and not the price increase. So consumers are not actually suffering from a price increase problem here, but the CPI basket doesn't understand that because it's just seeing the good in there as a Honda Accord. All right, so here's this problem with unmeasured quality change. CPI always will overstate the cost of living when we have this problem going on also. Okay, so here's the summary that each of these problems causes the CPI to be too high. All right, it's going to give a estimate of the inflation rate, or the estimate of the change in the prices by too much. All right, and in all honesty, the BLS has done a really good job. It's much better than it used to be, but some economists still think it overstates inflation about 0.5% each year. So it's close, but it's not exact. But 0.5% is a big deal because many Social Security payments and many wage contracts have cost of living adjustments tied to the CPI, right? So if the CPI is too high, then every year the people who are receiving this fixed income payments are going to be getting an increase bigger than they should, and that really can add up year after year. All right, so let's go ahead and think back to both measures of deflation we've learned so far. The CPI from this chapter, which we've talked extensively about, as well as the GDP deflator from last chapter. And a quick review what the heck the GDP deflator does. It, don't forget, compares the nominal to the real GDP in any one year. So the nominal GDP goes up because of both price and quantity changes, whereas the real GDP only goes up by quantity changes because of quantity changes. So the difference between the nominal GDP and the real GDP, the difference between those two was only attributed to price changes. So it conveniently works out that by comparing the two, nominal to real GDP, that's called the GDP deflator, we can also back out another method of price increases. And as you can see, for most years, the GDP deflator and the CPI are in very good agreement, okay? Right here, there's a slight increase in the CPI that's not present in the GDP deflator, but almost every year it's very, very close. So it's kind of leading us to understand that both of these methods create quite good estimates for the average level of the increase in prices, also known as inflation, experienced by our households. So, but what's the difference, and why are in those couple places were they slightly different? Well, here's why. Don't forget that many households buy imported consumer goods. So let's say I get a bottle of wine from Argentina. This is going to be in my shopping cart, and therefore it's going to show up in the CPI measure of inflation, but it's an import, don't forget. Imports are not included in any of the GDPs. It's not included in the nominal or the real GDP, so it's not even going to show up in the GDP deflator. So if it's imports that are getting really expensive, then CPI will go up, but the GDP deflator won't. Okay. Also, capital goods. Investment purchases made by companies are not in the household's basket, but they are in the GDP deflator if they're produced domestically, so it'll make the GDP deflator go up. Basically, the idea here is CPI uses a fixed basket of households. The GDP deflator uses a basket of everything that's being produced in the nation. Okay, and so if the prices are changing by different amounts, then we might have slightly different reports from both the CPI and the GDP deflator. All right, so think about these three situations and think about which one would change, the CPI, the GDP deflator, or both of them. Okay, if Starbucks raises the price of Frappuccinos, this actually is something that is in the household's shopping cart, so the CPI will go up. It's also produced in America, so the GDP will go up, so the GDP deflator will rise. Okay, so both of them rise. Now, if Caterpillar, which is a tractor company, manufactures tractors in Illinois, okay, this is clearly going to be in the GDP, but this is not something the average household buys, so it's not in their shopping cart, so it won't show up in the CPI. So the CPI won't go up, but the GDP deflator will. And then Armani, which is an Italian company, it raises the price of Italian jeans made in Italy but sold in the United States, right? This is in the shopping cart of households, but it's not in the GDP because it is an import, and so therefore the CPI rises, the GDP deflator does not. All right, here's a very interesting or important use for CPI and GDP deflator is just comparing dollar figures from different times, right? With inflation, it makes it harder to compare dollar amounts from different times. Example, the minimum wage. Let's say that, well, the federal minimum wage in December 1963 was $1.25, and it was $7.25 in December 2013. The question is this, what does that feel like if the person was working in 2013? So we have to change the $1.25 into what it would, quote, feel like for someone working in 2013. And another way to say that is, how much purchasing power does a $1.25 have in December 1963 when compared to December 2013? A third way to think of it is, how much would I have to pay a guy now in December 2013 to make him have the same feeling of purchasing power as he did when he got $1.25 in December 1963? So that's the question that we're going to ask, and here's the way we're going to answer it. We're going to use the CPI to change the $1963 into $2013. Okay, and here's the formula you're going to use. Amount in today's dollars equals amount of the previous year, or whatever year it was, dollars, times today's price level over that time price level. Okay, so year T is December 1963, and today is December 2013. Minimum wage is $1.25. The CPI was 30.9 in year T, and the CPI was 234.6 today. So just as a side note, you see that this number is less than 100 and this number is greater than 100. So the base year was probably somewhere between whatever base year that was used in this calculation, probably around 2000, has to be between 1963 and 2013. Okay, so let's go ahead and do this. $1.25 is that time, money that time. 234.6 over 30.9, the ratio of the CPIs, it gets 9.49. So it feels like $1.25 in year T feels like the same as at $9.49 in today's dollars. We call that the real wage. Okay, the nominal wage is just the numbers reported, but the real wage is what it actually can buy. In macroeconomics, anytime we use this idea real versus nominal, nominal is just whatever the name is or the number reported. Real means kind of how much products can be purchased with that. Okay, we're always kind of thinking about real variables. We don't really care about nominal variables. Everything's reported in nominal variables, but then we got to change it to what we really care about, which is real variables. All right, so the real minimum wage in 1963 was $9.49. Okay. So this is really common because a lot of people, academics and politicians included, like to convert a bunch of nominal variables that are recorded over different times in history into constant dollar, or we'll call those real numbers, okay? And then the purpose of doing this is to see how a variable can change after correcting for inflation, right? When prices go up and down, that actually doesn't affect anything, because when the whole price level goes up, that means even my wage goes up too, in the exact same proportion, and I can't purchase any more goods. So my life hasn't changed. My living standard has not changed. So I don't really care about nominal variables, I care about real variables. So let's look at the minimum wage. Here is the nominal minimum wage. Clearly, it's been going up. Obviously, we know that way back here in 1963, it was somewhere around $25 or something like that, and it's about $7.25 here in 2012. There's talks of raising that even further. But the question is, what was the real minimum wage? So what we're going to do is take the nominal minimum wage and adjust it for inflation, and we're going to put it in 2013 dollars. So a guy who was getting the minimum wage here in maybe 68 or something like that, he kind of felt like he was living in 2013 but making $11 an hour, and he was still making the minimum wage even though it was just like $1.75 actually. Okay, does that make sense? Now hopefully you realize there is one slight problem. In 1968, yeah, he might have felt like he was making $11 an hour, but he may not have even had the quality of life or the living standard that we do, just because he didn't have products that we have now. So someone could make an argument saying, hey, yeah, sure, he doesn't have, he made $11 an hour, but he didn't have access to iPhones or smartphones or something else very cool like that, which makes our life better even though we're getting paid less. So it might not be an exact comparison, but it's the best guess. Okay, so what I want you to do is go ahead and compare the prices right here of the colleges in 1990 to the prices here in 2013. What you need to do is convert all three of those prices into 2013 dollars, and then you can actually compare them. Because if you just compare 9,000 to 30,000, that's a naive nominal comparison, and that's not actually the increase in the price, because the whole general price level of everything was growing. You have to take away the overall price level increases, the inflation increases to be able to see how much it rose. Okay, so here this slide actually has an error. These are supposed to be 2013 dollars, right? You guys, I'm sure, know this. 2013 dollars. But I've taken the 9,000 and I've converted it into what would it be like in 2013. So the 93.40 in 1990 was like paying 16,622 in 2013. Well, the actual price in 2013 ended up being $30,000. So now the change from here to here is just a real change, meaning it's been corrected for inflation, and it's 81%. You see the change from here to here is much greater, but that's not a real change. That's a nominal change. It's not really what we care about. Okay, and so I've done that for all of these, and you see that the public four-year institution increased by 161%, almost 200%, almost doubling in price over that 23-year period. Okay, finally, this whole idea of taking a dollar amount and correcting it for inflation in a law or a contract is called index. So the CPI helps calculate the cost of living adjustment, or the COLA, in multi-year labor contracts. So if I get a job and they guarantee to pay me $60,000 a year for the next 5 years, they're going to have to put small increases every year just to keep up with the rate of inflation. That's called a COLA. And it happens in multi-year wage contracts, also Social Security payments, and finally in the income tax brackets. The income tax brackets themselves have to slowly slide up, because as inflation rises, that makes all of our wages increase, but we're actually not any richer. We're just general price levels going up. So the income tax brackets have to move up as well, or else I'm accidentally going to end up in a rich person's tax bracket when I shouldn't actually. Okay? And the last thing I want to teach you guys about is real versus nominal interest rates. This is real simple. You're familiar with a nominal interest rate. When you walk in to a bank, they give you a nominal interest rate that is not corrected for inflation, and all it's going to tell you is the rate of growth in the dollar value of your deposit or your debt. If you pull a mortgage out, they're going to give you a nominal interest rate. But let's think about if you go put money in the bank, they're going to say, okay, 5% interest is what you're going to get on this money. That means in 1 year, it's going to be worth 5% more than it was before. That's just telling you the rate of growth in the dollar value of your deposit. Okay? But however, what we care about, it's all we ever care about in this class, is the real variables. The real interest rate is corrected for inflation. It tells you the rate of growth and how much more stuff you can buy. And this is really what you're interested in. Not the actual how much the dollar value is increasing, but how much is the rate of growth of the purchasing power. All right, and so here's the simple formula. Real interest rate is nominal interest rate minus the inflation rate. Okay. Here's an example. Put $1,000 in the bank for a year. The nominal interest rate is 9%. At the end of the time, you will get 9% more dollar value, but during the same time, inflation is 3.5%. So the real interest rate, meaning how much more things can you buy at the end of the year, is only 5.5%. And that's the idea in real interest rate. It's the increase in the amount of things you can buy, which is what you actually care about. So we say the purchasing power has increased 5.5%. And here is just a brief example of the difference in real versus nominal interest rates in the United States. And so you see the difference between these is inflation. So you see at some points in time we had really high inflation in the 1980s. We did in fact have high inflation, and inflation is pretty low in other points in time. Finally, there are some very strange places where the real is actually greater than the nominal interest rate, and that means that prices were actually falling during that time.